Hi, from the VA characteristics of a junction diode, we see that it allows current to pass only when it is forward biased. So, if an alternating voltage is applied across a diode, the current flows only in that part of the cycle when the diode is forward biased. This property is used to rectify alternating voltages, and the circuit used for this purpose is called a rectifier. If an alternating voltage is applied across a diode in series with a load, a pulsating voltage will appear across the load only during the half cycles of the AC input, during which the diode is forward biased. Such circuit, rectifier circuit, is known as half wave rectifier. The secondary of a transformer supplies the desired AC voltage across the terminals A and B. When a voltage at A is positive, the diode is forward biased and it conducts. When A is negative, the diode is reverse biased and it does not conduct. The reverse saturation current of a diode is negligible and can be considered equal to zero for practical purpose. Therefore, in the positive half cycle of AC, there is a current through the load resistor RL and we get an output voltage as shown in figure. Whereas there is no current in the negative half cycle, in the next positive half cycle also again we get the output voltage. Thus the output voltage, though still varying, is rectified to only one direction and is said to be rectified. Since the rectified output of this circuit is only for half of the inputs AC wave, it is called as half wave rectifier. The circuit using two diodes as shown in the figure gives output rectified voltage corresponding to both positive as well as negative half of the AC cycle, and hence it is known as full wave rectifier. Here the P side of the two diodes are connected to the ends of the secondary of transformer. The end side of the diodes are connected together and the output is taken between this common point of diode and the midpoint of the secondary of the transformer. So for a full wave rectifier, the secondary of the transformer is provided with the center tapping, and so it is called a center trap transformer. The voltage rectified by each diode is only half the total secondary voltage. Each diode rectifies only for half cycle, but the two do so for alternative circuits. Thus, the output between their common terminals and the center tap of the transformer becomes a full wave rectifier output. Suppose the input voltage to A with respect to the center tap at any instant is positive, it is clear that at that instant voltage at B being out of phase will be negative as shown in figure. So diode D1 gets forward biased and conducts, while D2 being reverse biased is not conducting. Hence during this positive half cycle we get an output voltage and an output voltage across the load resistor RL as shown in the figure. In the course of this AC cycle, when the voltage is at A becomes negative with respect to the center tap, the voltage B would be positive in this part of the cycle diode. D1 would not conduct, but diode D2 would, giving an output current and output voltage across RL during the negative half cycle of the input AC. Thus, we get output voltage during the both positive as well as negative half cycle of the cycle. Obviously, this is more efficient circuit for getting rectified voltage or current than the half wave rectifier. The rectified voltage is in the form of pulses of the shape of half sinusoids, though it is unidirectional. It does not have any steady value. To get a steady DC output for the pulsating voltage. Normally a capacitor is connected across the output terminals.